Good day, everyone. Welcome to my YouTube channel. In this video, we'll continue from where we stopped in the previous video, titled Substructure Measurement 1. So in our previous video, we stopped at trench measurement. So as you can see here, we've measured the trench excavation from this point to this point using both our area 2 and our linear 2. So this is the total area here, while this is the length from this point to this point. So the next step now is that we're going to convert our measurement to cubic meter. But before then, let's check out the depth of our trench excavation. So as you can see, this is the foundation section, and the distance from our overside concrete to the base of our footing is 1.35. Let's just reconfirm that before we proceed. Okay, I think that's correct. Okay, so what we actually need here is the distance from the natural ground level to the base of our foundation footing, which is 0.63. So the actual depth of our trench excavation will be 0.23, 0.63, 0.63 minus our topsoil excavation, which is 0.15, and that gives 0.48. So the depth of our trench excavation will be 0.48. We can also add blinding to this. Let's add blinding to it. 50 blinding, that will be 0.05. That gives 0.53. So the depth of our trench excavation is 0.53. Like I said here, the width of our excavation here is given as 810. 810. Let's check that out on the plan too. Okay, as you can see, what we have here is actually the conventional width, which is 0.675, 0.675, and not 0.810 as shown here. Okay, let's convert this from area to volume. So what's left here is the depth of the trench excavation. So you click on advance, you double click on that area, double click on it, then you click on advance. So here, this is the area, the total area. So multiply this by the depth, which is 0.53. Then we change this from square meter to cubic meter. So what we have there is 1.16 meter cube. Let's convert this and see what the outcome will be. So we double click on these two, click on advance. What we have here is the GAT, the distance from this point to this point. So we multiply this by the depth, which is 0.53, and we also multiply this by the width, which is 0.68, and we change this from meter to cubic meter. So as you can see, the result is the same. Whichever tool you use, either the area 2 or the linear 2. It gives same value, 1.63, 1.63. So to my viewers, if you want to measure the remaining part of the trench here, what you need to do is that you click on the green button in front of what we just did now. Either of the two. You can use either of the two. Just click on this green button to reactivate the two. So let's use trench excavation 1. So I'll just click on the green button here. And once it turns red, that means the tool is active. And not what we're going to do here is to trace the area between this column and this column. And with that, it will automatically measure the trench excavation. So once you are done with this and you still want to measure something else, what you do is that you click on N on your keyboard, N for next. But if you are done with the measurement totally and you want to deactivate this tool, what you do is that you click on escape. But since we still want to measure, what I'm going to do is that I'll click on N. So let's end the measurement here. I want to show you guys something else. So I'll click on escape. The other tool we use here, which is our linear tool, I can also configure this tool to appear as an area tool. So to do that, what you need to do is that you double click on that tool, then you click on advance. Click on advance. If you check through what we have here under where is it? If you check through, yes, under takeoff data, if you check through, you see we have width under the list of takeoff data here. We have width there. We also have the depth there. So that means you can configure this in the sense that once you click on your trench excavation, it will ask for the width and depth. But since we've multiplied our takeoff by the width and the depth, what I just want to do is that I want to make that to appear. I want it to appear as an area 2. So to in doing that, what you need to do is that you tick this box here in front of width. So once you tick this box here, the tool will ask for the width of your trench excavation. Let's see how it works. Click on this, okay. So I'm going to double click on this now again. And as you can see, it's asking for the width. So the width of our trench excavation is what? 0.68. And click on OK. You can see it's a linear tool, but it now appears as what? Let me move it from this point so that we'll see. But it now appear as area 2. So that's one beautiful thing with PLANSWIFT. You can always configure all of this to work the way you want. I'll also measure that part of the trench using this tool. Click on next. Click on next. So I'll end my trench excavation here. You guys can go on with the other part. You can measure that part. I'll end mine here. Okay, so if you take a close look at this foundation layout plan, you discover that we have two types of foundation here. We have trench, we have strip foundation here, and we also have pad foundation here. So that means we are expected to take off for pit excavation for our pads. And if you also take close look at what we have here, you discover that we have different sizes of column base. We have different sizes, and I think we have a schedule here for that. This is the schedule. We have BT1, base type 2, base type 3, and these are their sizes. These are the total number of the different column bases we have here. But one other thing I will advise us to do in this type of situation is that before you make use of what you have here in the schedule, I will advise that you cross-check the numbers of column bases that we have here. I will advise that we cross-check the numbers of column bases because the structural engineer might make mistake. No one is above mistake. So in doing that, we're going to make use of our count tool to count the different numbers of column bases we have on this drawing. So from this schedule, we have BT1. So let's count the numbers of BT1 we have here. And in doing that, just what you are going to do is to left click on the count tool. Left click on the count tool. Then we'll rename our new count as what? As BT1. That will be under our substructure folder. Then click on OK. So we'll click on the BT1 we'll have on this plan. This one, BT1, another BT1, another BT1, another BT1, another BT1, and another one. So I think we'll have how many in total? We have 6 BT1 in total. According to what we have here, we have 6 BT1, and in the schedule we also have 6 BT1. I think that's correct. So I'm going to click on escape to deactivate that 2. Then I will reactivate this 2. Then name that 2 BT2. BT2. So I'm going to count the same way I did the other time for BT1. BT2, 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 BT2. I think I have another one here and another one here. Okay, I think I have one here, another one here. So we have 10 numbers, and based on what we have on the schedule here, what is there is also 10 number. I think that's correct too. So I'm going to deactivate by clicking escape. Then let's count the numbers of BT3 that we have on this plan. BT3. Click on OK. 1, 2. So I think we have 2 numbers. So with this, we are sure that the schedule, what we have on the schedule, is actually correct. It's correct. So the next thing I want us to do is that we're going to check the column section. We'll check the column section for the depth of the pit excavation column section. So with that, we'll need to switch to the other drawing that contains the column section. So to change what we have here, I don't know if we've viewed that drawing before. Okay, we've not viewed that drawing before. So we have to go back to pages, comma bookmarks. Then we'll locate that drawing. This is our column section. So let's rename this drawing. We'll double click on this to rename the drawing. Column section. Okay. So from this section now, the distance from our oversight concrete to the base of our column base is what? 1.4. So let's scale that so that we'll be able to check out the dimension from the natural ground level to the bottom of our column base. So I'm going to use my scale tool now. 1.4. Click on OK. Distance from this point down to the, okay, let's try it up to our so okay, no, don't need that. Up to this point. That's 1.4. You can also reduce the size of this text. If you want to reduce the size of this text, what you do is that you double click on the scaled dimension here. Just double click on it. Then by our bottom right corner of the software, you see text height here. Text height. So you double click on that value. That value there is 1. You can double click on this. Then let's change this to a smaller value. Let's change this to 0.2. So the smaller the text height, the smaller the font of the dimension. So after changing that, you click on enter. So as you can see, the text height has reduced. Okay, let's check out the dimension from our natural ground level to the bottom of our blinding. That's 0.86. 0.86. So that means the depth of our pit excavation is 0.86 for the whole column base, because the thickness of this is the same. This distance is also the same for that column section for BT1. For BT2, this and this is also the same. This and this is also the same. So the depth of our pit excavation for the whole column we have here on this plan, they are all 0.86. So let's go back to our foundation layout plan. 0.86. That's the depth of our pit excavation. Okay, so let's turn off all the count tool here. I'm going to turn this off. Okay, so let's delete uh 20 excavation 2. Okay, so for our BT1, the size of BT1 is 100 by 100, 100 by, sorry, 1000 by 1000, which is 1 meter by 1 meter. We can our advise us to measure the pit excavation here using our area 2. So once you activate your area 2, we'll use that to trace the whole area here. Then we'll multiply what we have by the depth of the pit excavation and by the number of that column base. So let's do that. Use our area 2. Use our pit excavation, and this is for BT1. For BT1, let's copy this because I'm going to make use of this same description for the other column bases. Just a normal Control C to copy. Then the depth of our pit excavation is 0.85 multiplied by 0.85. We also multiply this by the number of BT1. We have 6 numbers. 6 times 6. Then you click on OK. So with this, we're going to trace 1 BT1, and that's all. From this point to this point to this point and the last point. So click on escape to deactivate that too. So with this, our total excavation for BT1 here is 5.2. Total quantity of soil here is 5.2. One other thing, I forgot to change the unit here from square meter to meter cube. I believe we all know how to do that. I'll do that when I want to excavate for column base type 2. So like I said the other time, I've copied the description So I'm going to paste it, Control V, and I'll change this from BT1 to BT2. And if I can recall, okay, this is it. From what we counted the other time, the number of BT2 we have here is 10. So advance, I'll take off, multiply by 10, multiply by the depth of our pit excavation, which is 0.85. Drag this up and click on OK. So we're going to trace 1 BT2. And with that, we're done with our excavation, our pit excavation for column base type 2. Escape. We have one more column base to excavate, one more type of column base to excavate, which is BT3. The same approach. Change 1 here to 3. Advance. Take off. Multiply by 2. Multiply by 0.85. Then click on OK. And I'm going to trace this from this point to this point, down to this point, and lastly to this point. Escape. So with this, we're done with our pit excavation. It's as simple as ABC. Let's change our units to cubic meter. It should be in cubic meter, not square meter. Cubic meter. Cubic meter. Cubic meter. In the next video, I will show you faster way of measuring substructure work. See you in the next video.